you know how scientists measure and record earthquakes? The answer is
seismographs. When an earthquake occurs,
whoa!
Seismographs record the magnitude of the earthquake and show the progression of seismic waves.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Hey John, tell me about how physics relates to seismographs.
Seismographs work by using the property of inertia.
Inertia is a property of matter that states an object at rest stays at rest unless acted upon by an external force. In a seismograph, when the ground shakes due to seismic waves, the frame of the seismograph moves with the ground, but the heavy mass tends to remain still due to the inertia. Just like John throwing me the ball! That's inertia.
These waves are like invisible ripples and travel through the ground when something happens, like a volcano or an earthquake. They most commonly appear as P waves and S waves. P waves, or primary waves, are sound waves that travel through Earth from an earthquake. They are the first waves to arrive on Earth as soon as there's an earthquake. They move quickly at speeds as fast as 3.7 kilometers per second. Wow! S waves, or secondary waves, are high-intensity shaking that we feel and are the more damaging waves that earthquakes produce. They move at a slower speed, around 2.5 kilometers per second. Here's what they look like on a seismograph.
Bill Nye the Science Guy.
What am I gonna do next earthquake? I don't want to fall over like I did last time.
Here, you don't need to be sad anymore.
Introducing our new brand, Inertia Vest. Based on real Newtonian science, Inertia Vest uses your body's inertia. Yes, that thing keeps you still while everything else wobbles for extra security during an earthquake. Just look at all this high-tech material that will prevent you from falling when everyone else does from all those seismic waves. I didn't fall.
Science rules.
First, start with the shoebox. This will be our frame for the seismograph. First, we want to make 2 slits on both sides of our shoebox.
Nice!
Next, you need a plastic cup. This will work as our mass for the seismograph. Okay, now I punched 2 holes in each side and tied the yarn to the cup so that it looks like this. Now we take our box and we poke 2 holes in the top that are the width of the cup. Now that we have the yarn through the holes, we want to pull it so that the cup is about 2 centimeters above the bottom of the box. Next, take a roll of paper and weave it through the slits in the box. You can also do this step before you tie the yarn to it, but I'm cutting a hole in the bottom of the cup for the pen to go in right now. Now we insert the pen. Now add coins as instructed on the poster. It's okay if there's a little marker on the bottom when you first start. Now have one person pull the paper slowly while the other shakes the table, which simulates an earthquake occurring. The squiggly lines represent the seismic waves of an earthquake. When it straightens out, that represents that the earthquake is over. Now you try it. Make sure to experiment the amount of mass that we put in the cup and also try different shake patterns.
Wow!
Inertia is a property of matter.
If you can't make a seismograph, you can always make a seismometer, which tells you something similar, but it measures the waves and shows you which way they come from. For this project, you are going to need
clay or Play-Doh, a marker, a marble, bottle caps, and hot glue. You're gonna put the clay in the center of your box or in the center of your table, whatever you're doing it on. And then you're gonna put your marker in the center of it, straight upright, so then the marble can balance on top of it. Once that is complete, you're gonna line the bottle caps around the marker so they can catch the marble when you move the box. For this step, I'm also hot gluing down the Gatorade cap so they won't move when we shake the box. Now, when you shake the box like this, the ball should fall in one of the bottle caps. When trying this out, push the box in different directions to see which way the marble will go. This will symbolize earthquakes coming from different fault lines, and you'll be like a scientist trying to figure out which way the earthquake came from. The seismometer and the seismograph are both very effective tools that are used to discover more about earthquakes and measure them so we can take preventative measures in the future.
Bill Nye the Science Guy.